All right, so let's talk about the Mongo assignment that's going to go out today, and again, it will be due towards the end of the semester. So again, we have relaxed all the due dates. So this is the MongoDB. This is the last assignment, right? And it builds on the previous assignment. You know, if you remember, in the previous assignment, we were adding the feature of being able to list an array of quizzes and then list an array of questions for those quizzes. We were adding links to the end of each one of the courses that when you clicked on it, you navigated to a list of quizzes. Then in there, you could either start the quiz or click on the quiz, and then you navigated to a list of questions that were for that particular quiz. So here's an example, quiz number 3. If you clicked on it, you got a list of questions for that quiz. And each question had a grade button that if you clicked on it, right, it highlighted whether the answer was correct or not, and it showed you what the correct answer was and your wrong answer or whatnot. So it graded each individual question. So we're going to expand on this idea, but instead of just having this on the client side, I mean, we're already downloading the questions and the quizzes from a server, but we're not sending any of these answers back to the server. We're grading all these on the client, right? And so we're going to expand on this idea, and instead we're going to send the answers that we selected on the client. We're going to send it over to the server for grading, and we're also going to store those answers in a database, in a Mongo database. So let's look at the Mongo database. So for the Mongo assignment, what we're going to do is that we're going to create a schema that is going to allow us to represent the questions. Right now, the questions that we have are now being stored in a hard-coded array, right? That is being sent over from the server using a controller, a RESTful API. But right now, it's just an array, hard-coded array. Instead, we're going to store these quizzes in a database, in a Mongo database, right? And then we're going to retrieve those questions and those quizzes from a Mongo database. So we'll need to implement a schema, Mongo schema, to host this information, and the questions are going to be able to either be a true/false question, a multiple choice question. We're going to use an enumerated data type. That is a new concept in Mongo database. So we'll talk about that. We'll also represent each one of the quizzes as a collection of questions. So notice that here we see that a quiz is just basically an array of questions with a title for that quiz. And I believe a score. It's not listed here, but we also have a score. You know, what did you get for that quiz? So this is a score, and it's a number.
这是第 A9 是吧？对，
I'm sorry.
Yeah， 他还在改。
I'm sorry. I think somebody's having a side conversation. If you could mute your mic, please. Notice here that a quiz is just basically an array of questions, and notice that we're storing in that array of questions. We're storing the index, right? A reference for the unique identifier of what the question is, right? This is different than how we had implemented earlier. We had each question have an ID that referenced the parent question. Right? So in both cases, we have a one-to-many relationship between a quiz having many questions, but the way we're modeling it, you can model it two ways, right? In a relational database, the only way to model this, well, you have two ways, but typically, if you have a parent-child relationship, it is the children, right, the questions, right, who have a foreign key back to the parent, right? And that's the way we modeled it earlier with two arrays. We had the child questions have a quiz ID that referenced the parent quiz, and that's fine. That's one way to implement it. The other way to implement it in relational database is to have a mapping table or mapping array, right? That says which questions belong to which quiz. That's also another way of implementing it. Now, in the implementation where you have the questions have a foreign key to the parent, that only allows you to have one question belong to one single quiz. And that's fine, right? If that's the use case that you want to implement. But what if you wanted to have a single question be maybe shared amongst multiple quizzes or multiple exams, right? Maybe I want the same question be in quiz number 3, but I also want it to be in the midterm and maybe later on again also in the final exam. In that case, the child question referencing the parent quiz is not enough to model this structure, this hierarchical structure. Instead, in a relational database, you have to have a mapping table, right? That says which questions belong to which quizzes or which exams. So those are the only two ways that you can implement it with their own limitations. Now, in a non-relational database like Mongo, you actually have an additional alternative, right? So in Mongo, not only can you model those two ways that we just referenced, right? Either the foreign key or the mapping table. We could do the same thing in Mongo. We could have, the quizzes have a foreign key back to the parent, and we can also have a mapping collection. But in Mongo, we have an additional way of capturing this information. We can have the parent quizzes, right, have arrays. Here it is. Notice that this is a square bracket there, right? And that square bracket says that this is an array of the following. It's an array of what? We're keeping track of the IDs, right? The unique identifiers. So basically, this is an array of foreign keys, right? Which is pretty cool. It's an additional way of capturing this information instead of having a mapping collection, right, or foreign key from the questions back to the quizzes. Additionally, here we are not only are we storing the IDs, but we're also telling Mongo that this is a reference to a model that Mongo is also keeping track of, right? It's keeping track of the questions, right? So it knows that these foreign keys are actually referencing records, right, that are being stored in a particular collection, and that I could ask the model, the quiz model, to please fetch me all the questions, the actual objects, right? Retrieve them, and instead of just storing and giving me the IDs of these questions, to please retrieve the actual questions from the records, right, from the database, which is pretty cool. We'll see how to do that. We'll demonstrate that a little later. All right, so we're also going to be capturing the attempts, right? When you submit a quiz or you submit an exam, right? You will have selected certain answers from the available choices, from true, false, or the multiple choice. You have given your answers. So what we're going to do is that we're going to store your selected answers. We're going to store them and send it over to the server, right? And we're going to store it in the database. The attempt is going to have a reference to the quizzes that says that this attempt that the student made, right, was for this particular quiz. So we know for which quiz was this attempt. So we're going to have a reference to it, just the ID, the unique. So it's a foreign key. But also we're going to keep track of the original questions, right? We're going to keep track of a copy of the original questions, right, and the answers that you've selected, right? So that if you want to review the quiz attempt later on, you want to see what the answers were for this particular attempt, right? We can show you and we can render in the user interface. These were the options, and this is what you answer specifically. And notice that we're keeping a copy of it, right? So that even if the question later on changes, right, because somebody, there was a misspelling, or maybe I want to change the options later on, right? Even if the original question changes, right, we're going to keep a copy of what was the original question when you answered it, right? Regardless of whether this question changes later on, right? We can keep track of a history of what was your choices for that question, right? Whenever you took this in the past. So we're going to keep track of a copy. So it's an array. Notice it's an array of schema. See that? So basically what we're doing is that we are importing the the structure of each one of the questions, right? And we are embedding it inside of an array. So we're going to keep track of a copy of that JSON object that you submitted when you submitted the questions, right? And we're going to keep a copy of that, of all those questions in there, right? It's pretty cool. Also notice that we're going to score your attempt, right? And we're going to say, oh, well, this is what the person who submitted it, what they got. Right? We're going to just iterate over all your answers, and we're going to compare your answer against the correct answer. If you got it right, we're going to count how many questions you got right. Right? We're going to divide that over the total number of questions. We're going to assume that each question has an equal weight, right? And we'll give you a score. Right? So the score is really on the attempt. It's not on the quiz. That's why I had not put a score here on the quiz. Makes no sense to have a score on the quiz, right? Because we want to score on your attempt of having submitted these the answers. That's why we're going to remove that. Also to point out, notice that we need to store your particular answer to a particular question. So we're going to augment the question. Not only is going to keep track of the title and what the original question was and what was the correct answer and the choices and whatnot, we're going to also add here the actual answer that you submitted, right, when you took this particular question, when you answered this question, right? So we're going to store it not in the original question, right? Instead, we're going to be using that to store it when you submit it, right? You can provide your answer, and we can store it for later purposes and score it, right? So that we can give you a score for that attempt. Okay, so that's those are this is the structure of the data for quizzes, questions, and then when you submit a particular attempt. Okay, right. So that's the structure. We're obviously going to need models for each one of these, right? So each one of them is going to have a model for the question, for the quizzes, and for the attempts, right? So that's no big deal, right? So we always need a model, and these are going to give us the low-level generic functions that are going to allow us to insert, update, delete, find data from these particular collections. So typically, it's a best practice not to necessarily use the generic low-level interfaces that these mongoose models provide us. Instead, it's a good practice to wrap these low-level generic functions that interact directly with the database. It's a good practice to wrap them in a high-level interface, right? So that we can implement the find all questions in terms of the low-level, model.find, or find question by ID in terms of the more generic find by ID, and so on and so forth. Is there a question? I hear background noise. Again, please remember to mute your microphones. Also, notice here we do have we want to be able to find or retrieve the questions for a particular quiz, but since the questions are embedded inside of the quizzes, right? The way to retrieve the question is to first find the quiz, and then once you have the quiz, just return the questions inside the quiz, right? Again, these DAOs, what they do is that they wrap the low-level operations that are very, very generic. Instead, they give us names for these operations that are more high-level. They are specific to our particular domain. It gives them proper names such as questions, question by ID, quizzes, right? The high-level data model that we're using. Same thing for quizzes, and same thing for the quiz attempts. So the DAO is typically implements the data layer, right? The interface and interaction with the permanent data store, right? Typically, it's also a good practice to wrap these DAOs with a service layer, right? That might implement some business logic, might implement some relationships between multiple DAOs, multiple collections. So it's usually a good practice to wrap DAOs with a service layer. And so that's what we're going to do. We're going to implement a service layer for the questions and the quizzes. Okay. which are going to be written in terms of DAO. Some of you might feel that this is an overkill. We already have a DAO. Notice that our services are mostly just a pass-through, right? Find all questions is just a pass-through to the question DAO. Find all questions and question by ID just a pass-through to the question by ID. So here, perhaps with what we're doing here, where our data model is fairly simple, our use cases are fairly simple. Maybe a service layer might be an overkill, and certainly for this particular example, there's maybe way too many layers, right? And that's true. For our case, it might be an overkill. But nevertheless, here we're talking about principles. We're talking about how would you architect applications that might be fairly complex, where you might have multiple folks working together to build a complex enterprise application. And usually when you break it up into multiple layers, where each layer has its own concerns, right? It's a good practice to have a division of concerns where each team might be dedicated to solving these particular concerns. It's always a good idea to break them up into multiple layers, and you have maybe different team members working on different parts of the layer. So even though here it's an overkill, again, it's a good practice to break it up. In when you're talking about a much larger complex application. So even though we don't need it here, it's a good idea to just practice it. We also have controllers that are going to expose our data model as a RESTful API. We had already written several controllers that exposed our quizzes, our questions, but they were written in terms of a service layer that was synchronous, right? If you remember, all our service we're retrieving data from hard-coded arrays, right? And so all our APIs were synchronous. But now, because we are using now a database, right, and it's MongoDB, right, all our communication with the database is going to be asynchronous, right? So if you remember the implementation for these services, right, the find all questions used to be just returning the entire array of all the questions, right? Or find all quizzes was returning the entire array of all the quizzes. Well, now instead we are going down to DAO, which is written in terms of a mongo model, right? That it's an asynchronous call, no longer here, right? So now these are not synchronous, right? Now these are all asynchronous. So we need to refactor all our controllers, right, to take advantage, right, or of the fact that now all these communication is asynchronous. So the way we do that is that we're going to go out first to the service to fetch the data, and that's going to return a promise with the response, right, of the data, and then we can just send it back to the client. So we'll need to refactor two controllers, the question controller and the quiz controller. Right? We'll just have to shuffle a couple things here and there. That's going to be fairly simple. We are going to create a brand new controller, right? That's going to allow us to expose the brand new quiz attempts, right? Which is going to allow us to first post a new attempt. Right? This is when we submit a quiz. We are going to send over the attempt, right? Our answers. And what we're going to do is that we're going to send the entire quiz over, which is going to be an array of questions. But now the questions are going to have not only the original copy of the questions, we're going to have the actual answer that we selected, right? For either a true, false, or the multiple choice, which choice we chose or which answer that we selected, the true or false. So that these attempts is going to be an array of the original questions plus the answers embedded in each one of those questions. And we're going to insert it into the database. We're also going to have a capability of retrieving each one of the attempts. This is so that we can see what do we get in this particular attempt. I submitted my quiz. I want to know what I got. Right. So this is going to retrieve the attempt. It's going to say, oh, in this attempt you got a 75, you got an 80, 90, whatever. Once we have the controller, we need to register them with our server, right? With our Express server. So on our client side, right, we're going to have to do a couple of refactoring. If you remember, we have a couple of questions that we implemented. We implemented the multiple choice question and the true false question. In both cases, we had bound the question being passed by a parent element component, right? Remember, there's a component that iterates over all the questions. Remember, here's the quiz component. Here's the quiz component, right? The quiz component iterates over all the questions, right, that it's retrieving from the server, right? And then depending on the type of the question, it's rendering either a true-false question or a multiple-choice question. And it passes a reference of the question down to each one of the components. And then each component renders it its own way. So we had done that already, right? Each question component uses the input annotation, right, to bind the attribute question as it's being passed down to it so they can render it. So we're going to also bind an answer. Remember that in the previous assignment we did have an answer variable, right, that we used to bind to the choice that you were selecting, right, either the true false or the multiple choice, whatever you selected, your answer was bound, right, when you did the selection. And so what we're going to do is that we want to expose this answer. We want to expose it to our parent component because before, the grading of each question was individual. Each question has its own individual grading. You know, you clicked on it and it told you whether you got it right or wrong. But now we're not going to do that anymore, right? Instead, we need to be able to collect all those answers. Right? We need to collect all those each individual question, right, and grab all those answers, build an array of all those questions, and then send that as an attempt. You know, when you submit the question, we need to be able to iterate over each one of the questions and say, well, what did you answer for this question? What did you answer for that other question, right? And we need to store all those answers into the original question that was used to render it, right? And then we're going to send it back to the server, right? So the way we're going to do that is that we're going to bind the answer that you selected using the input and output, right? So we're going to bind it to an input output, so that's going to allow us to notify if the answer changes. You know, we need to go back to the parent model that has all these questions. We're going to say, hey, the answer changed, right? So you need to change whatever answer you have in your question. So we're going to use the emitters, right, to notify our parent that the model changed, right? And this is a new answer. So we're going to bind it using two-way binding. Meaning we're going to be able to read the answer from the parent, but we're also going to be able to send the answer back, as it changes, as you modify your answer. And we're going to bind it to the answer attribute of each one of the questions, right? So we're going to iterate over all the questions, and each question is going to have its own answer. So as you change the answer, it's going to modify the original answer, which initially will be empty, and we're going to be able to set it this way by binding it to the original answer. And finally, we're going to submit the quiz, right, which is going to take all those answers, the array of all the questions, and we're going to send it over to a server, and that's going to be implemented as follows. When you click on the submit, we're going to post, right, the new attempt. We're going to send all the questions. Now, all these questions now contain in it all the answers, right, that we had selected. We're going to stringify and send it over to the server for that particular quiz. Right? And then in the server, we're going to grab that and we're going to store it in the database for scoring and for historical purposes. Okay. There's one more part that I haven't written here, but what we'd like to be able to do is that we want to, once you submit your quiz, we want to be able to display the results of having scored that attempt. Right. The scoring is going to be done on the server. And that's going to be done in the attempt service. In the attempt service, when you submit your attempt, where is it? Service. There we go. So when we in the quiz attempt DAO. Right, when we we're going to insert the attempt into the database. Right, we're going to store. This attempt was for a particular quiz. We're also going to store all those questions, right, with the answers, which is we're calling it the attempt, right? We're going to store it in the database, but the score, we're going to score it right here in the DAL. We're going to pass all your answers to a score quiz function, which is basically going to iterate over all the questions, and it's going to compare each answer that you got, compare it against the correct answer for that particular question, right? And it's going to, if it's the same, right, we're going to just count up how many right answers you got, right? And at the end, your score will be, how many you got right over how many questions there were. And we're going to multiply by 100, and that's going to be your score. So we're going to store the score in the database, right? So the last piece here is that once you have the attempt, we're going to be able to report that to the client, right, and say, for these quizzes, and you had all these attempts, these are the scores you got for all these attempts. Okay, so as a deliverable, right, we're going to have we need to deploy the Angular application, the Node.js application, push this to a GitHub repository, and then deploy this on Heroku. And also the database needs to be connected to a remote database, and we're suggesting that you use the MLab plugin, right, that you can add to Heroku, right, and so your Heroku application, when it's running on Heroku, right, it should be using the remote MLab database. Okay, as always, please provide links to all your repos, all your applications running on Heroku, so that the TAs can clone your application and try it out locally on their machine. All right. All right. Any questions? Let's see. Looks like was there a question in the chat? No, you're sharing right now. The team 479 looks different. Yeah. As I mentioned earlier, so there's a link for the assignment 9 already on Blackboard, which is it's an older assignment that doesn't quite integrate nicely with the rest of the assignment. I know that some of you might have already started on that assignment, and that's fine. Just keep going with that. This is a new version of the assignment, which is better integrated with the rest of the assignments that we've been working all throughout the semester. So I'm going to give you an option, which one you want to work on. I think this is a much more interesting assignment, and it's integrated with the rest of the application. I'm also going to give you quite a bit of code to get you started, and so that you can work on this assignment. Okay. So I'll provide source code, starting today with to get you going with this current assignment, right? But my preference is that you work on this assignment. But since I had failed to update the link, you might have already started with the old assignment, and just keep going. Okay, and you'll be graded using the rubric for that particular assignment. Okay. All right, so let's get started with this assignment, and first let's review where we left off. Let me close this here. This is the Node.js server. Close this. We have that. Okay, we are on the right branch. Okay, so it's the Node.js. Let me open up the other project. 5610 Angular. Okay, let me see if we're in the right branch. Okay, everything's up to date. Oops, no. What? Screen recording. Why is it doing that? Capture selected window, entire screen. What? I don't want a picture. Ah. Hi everyone. Sorry, looks like I accidentally quit out of Teams. Can you hear me? Right, can everybody hear me? Let's see. All right, can everybody hear me? Let's see. Can somebody respond? Can you hear me? Hello? Hello? Can you hear me? Oh, unmute. Hi, can you hear me? Can everybody hear me?
Yes, Professor.
Okay, good. Thank you.
But for some reason, we can't see the option of the chat.
Oh, okay. Andrew Steedholm answered that he can see me. He can hear me. Okay. All right, I can see the chat in here. Okay, Andrew. Thank you, Andrew. All right, so let's review where we left off. Why is it doing that? New movie recording, screen recording. Stop screen recording. Oh, because I'm already recording?